Okay, we are here doing a worksheet on using matrices to transform geometric shapes. So our goal is to take this shaded triangle, it's a right triangle, and the sides are 4 by 6 with a hypotenuse that we don't really care about, but we do notice down here that this is 6 by 9. Count those spaces carefully and you will confirm that. So we need to make this shaded one 1.5 times bigger. If you're having a hard time understanding where that came from, just take the bigger numbers that or take the target numbers and divide them by the starting numbers, and you'll get that scaling ratio. Okay. So how do we do it? Well, sometimes it helps to look at your target and kind of imagine you're going backwards. Remember that we're going from the shaded, so you might sometimes make the mistake about which direction we're going in anyway. But if we were to flip this upside down here over this axis, the x-axis, then we'd have the right angle in the upper left like we want to, and that orientation is critical. So if we flipped it up and then we shrunk it, we could slide it in position. So we're basically going to slide it over, make it bigger, and flip it down. If you want to be really clever, you could do the flipping first and see where your target is, and then from the target you could shrink it by 1.5, multiply it by 2/3, and that would give you the exact location where you'd want to slide it over to. Okay? If you weren't that clever, you could do it also in a pretty smart way, and that is to slide this corner here down to the origin, and then when you've got one part of your figure on the origin, when you scale it up, it's nice because that stays stuck at the origin, because the origin is the one point when you dilate, it does not change. Okay, so let's try that then. Let's take and slide this right down there into the corner, and like I said, if it's 4, 1, 2, 3, 4 by 6, 2, 4, 6, if we slide it to be right here, okay, that'll be a very good start. So what does that? We're going to add to it the matrix that moves it over 2, 4, 6, 8. So every x goes over 8, and then every y goes down 2. So that's just a standard translation vector. When I do that, I get the new matrix that is going to be 0, and then adding 8 to that gives you 6, and then 0, and then it's going to be 4, and 4, and 0. Okay? So that's going to be A prime, B prime, and C prime after my first transformation. Does that make sense? 0, 4, 6, 6, 4, and 0, 0. So there's A prime, B prime, and there's C prime. Okay, so now when I make it bigger, I'm going to multiply this. That was addition. Now I'm going to multiply by the scaling matrix, which is always just whatever the scalar is in the diagonal. In this case, 1.5, 0, and 0, and 1.5. When I multiply each of these numbers by 1.5, that's what this matrix does. It just takes every number and makes it 1.5 bigger. 0 times 1.5 is 0, and then 6 times 1.5 is 9, and so on. And 4 is going to become 6, and 6, and 0. So this is my new A double prime, B double prime, C double prime. Don't get hung up on that. If it doesn't make sense, just this is our way of keeping track of how the letters are changing, adding a little ticky mark every time. So if I graph that, then it's going to be 0, 6, it's up to there, and then 9, oops, sorry, 3, 6, 9 is right there, and then up to right there. So it's kind of getting a little bit obliterated. But this is it when it's in bigger. It's just like that. It's this whole thing. Okay, and so then I'm going to flip that down, and when I flip that down, it's going to be right here, like that, and that's going to be multiplied by the matrix that doesn't change the x's, 1, 0, but takes every y and makes it negative. That's going to be that one, and that's going to equal then all the x's staying 0, 9, 0, and all the y's being negative and negative. And whoops, when it flips, that's terrible. Why did I put it down there? Sorry, it's going to be way up here. Holy cow. 6 right there, so that won't be in my way. Yeah, I don't know why I made that jump, that's silly, but anyway, so it's going to be here when it flips down. 0, 6, and 0. So then how do I get this to come down to here? Well, you can see the x's are going to move over 2, so I'm going to do plus another 2, 2, 2 in every x, and then every y goes from 6 down 7 more to 13 in this case. So 7, negative 7, negative 7. Okay? So that is the way you do that one. And hopefully that showed up. At least I'm going to slide it up there now. So you can see the matrix that I added to this to translate this one down to where it needs to go. Okay?